Your coding agent ran 40 times overnight and it reported every single task complete. Green across the board. But here's the uncomfortable question nobody wants to sit with. Who actually checked it? Because the model that wrote the code is the same model that turned around and told you the code works. And that exact loop is how an agent learns to lie to you. Not maliciously. It's just biased toward approving its own results. So the fix is structural. A separate verifier, a separate checker, has to grade the work. And because an unwatched loop can repeat the same mistake silently, run after run, you build that verifier first, before anything else. Look at the shape of the trap. The generator produces output. Then the same generator turns around and evaluates that output. Of course, it says it passed. It's grading its own homework. 40 iterations later, you don't have 40 checks. You've got one biased opinion, repeated 40 times, wearing a green check mark. So step back for a second, because something genuinely changed here. We used to optimize the prompt hunt for the one clever sentence that gets the model to behave. Loop engineering reframes the whole task. You're not writing a prompt anymore. You're designing a system, something that decides what to prompt next, runs it, and then evaluates the result. The prompt stops being the product. The system around it becomes the product. If the verifier is the weak point of the whole system, then that's where you start building. Not the agent, not the prompt. The judge, and it has to be separate. A distinct checker agent grades the work, precisely because the model that produced the output can't be trusted to be hard on itself. That's your human judgment layer. But don't stop at one agent reviewing another. You bolt on automatic feedback loops the model can't sweet talk its way past. These are the gates that don't have opinions, only verdicts, types, tests, linting, pre-commit hooks. Each one raises the quality of what the loop produces, because each one is an objective signal the model can't argue with. And the rule tying them all together is deliberately blunt. If any feedback loop fails, the agent does not commit. No green light. No moving on. The gate stays shut. Now, the long-run problem. Quality doesn't fail all at once. It rots. It's called context rot. As token usage grows across a run, the output quietly degrades, and you fight it by starving it. The Ralph loop's core constraint is one task, one feature, per iteration that keeps the context tight and focused. Keep every change small. One logical change per commit. And here's the move people skip. Have the agent record its progress to a file each iteration. That way, the next run reads the notes, instead of burning tokens, re-exploring the whole code base from scratch. So when is it actually safe to stop watching and let the thing run unattended? The honest answer, not on day one. Best practice is to start attended. You watch each run, you tune the prompt, you learn how your loop fails, and you only graduate to unattended. Once the automatic feedback mechanisms have earned your trust, even then, and this is the part people want to skip, unattended doesn't mean unverified. An unwatched loop can repeat a mistake silently for dozens of iterations while reporting green the entire time. Human verification doesn't disappear. It just moves up a level. Here's the one principle that ties all of it together. Loop engineering is building a system that decides what to prompt, runs it, and evaluates the result. And that evaluation step is the load-bearing wall of the whole thing, which means the verifier is the real product, not the prompt, not the agent, the judge. Because the generator will always be biased toward approving its own work, the quality of your loop is capped by the quality of the thing grading it. Build the judge well, and everything else, the prompting, the iterating, is just turning the crank. So here's exactly what to do next in order. 1. Build the verifier first, a separate judge, because an unwatched loop repeats its mistakes silently, and you need something honest catching them. 2. Wiring your automatic gates, types, tests, lint, pre-commit hooks. with one hard rule. Any gate fails, no commit. 3. Keep iterations tiny and make the agent write its progress to a file. 4. Start attended, tune until you trust the gates, and only then let it run unattended. Build the judge first, and your loop can't lie to you. If that reframed how you think about agent loops, subscribe to NeuralStack. We go deep on this stuff.